Okay, so today we're going to be looking at the effect of carbon dioxide, or increased carbon dioxide, on the pH of water. Now, first thing we need a source of carbon dioxide. And the quickest and fastest way that I figured to do this was using compressed carbon dioxide. Now, this is a cylinder that just has compressed carbon dioxide gas, and it's used for this home unit that's used to carbonate beverages. Now, carbonation is really just a process by which we dissolve carbon dioxide into water or liquid under pressure. So this has very high pressure and a very high concentration of carbon dioxide, so it's going to allow us to see the effects very quickly. So the first thing I need to do is to add my cylinder to the unit, which is very easy, and put it together. The next thing we need is water. Now, I'm just using regular tap water here from my tap. It goes through my pure filter. So this should have a relatively neutral pH. I'm going to add this to the bottle that comes with the unit that allows us to add the carbon dioxide under pressure without creating a big mess in the kitchen. So I'm going to fill that up to the fill line that's indicated on the bottle. But before I add the carbon dioxide, I really need a baseline. I need to know what the pH of the water is normally. So I'm going to take my pH probe here, and this is a digital probe, which will allow us to get a very accurate measure. Now, it was just in the buffering solution that helps protect the probe. So right now it's like a 3.85, so we're going to add it to the water and see what the pH of the water itself is. Now, in this experiment we're going to be doing, the independent variable, the variable that I am changing, is the carbon dioxide. The dependent variable, or the variable that's going to change because of what I'm doing, is hopefully, if we're correct, the pH of the water. Now, we want to keep everything else the same, so we're going to be using the same water, same setup, same bottle, and not change anything else, because we don't want anything else influencing our results. I'm just going to give this a minute to stabilize, because we want to make sure we have an accurate reading. Now, you'll see here what we're using here to measure pH is probeware. This is from Vernier, and it is a probe connected to an interface, which then connects to the computer. And the software allows us not only to collect data, but it will graph the changes in pH. Now, this is a lot more accurate than some of the other methods that we talked about on the website, such as using pH paper or liquid indicators. Those do a pretty good job of telling where it is on the pH scale in general, but it does not get as precise a reading as this. Now, we're seeing right here, we're running a little bit around 7, so I'm going to say that our pH is roughly around 7, a little bit over. So this is ever so slightly over or closer to basic. And I'm just going to put my probeware there in the same water that I am putting in my bottle. Now I'm going to attach my bottle of water. I'm going to make sure it's very tightly attached so that I don't spray water all over myself and my computer. And this will help release the carbon dioxide from the cylinder in the unit into the bottle. Now, of course, the objective of this normally is to create soda water or seltzer that I can use to maybe cut down on my soda drinking. But for today, it's a very handy way of very quickly adding carbon dioxide to this water. So you can see it's adding bubbles of carbon dioxide. And that noise tells us that we have very pressurized and that it wants me to stop before I make a mess. So what we're going to do now, I'm going to unscrew the bottle, and you heard that noise. That means it was under pressure. And if you look closely, you can see the bubbles of carbon dioxide in the bottle. Now, before I take my new pH reading, I'm going to take a look. So it was showing it actually equalized about 7.2. And if I click over here up on the software, it'll start collecting. So let's click on there, and it'll start collecting data for my graph. And I'm going to insert the probe into the bottle. Now, I'm going to try and get out of the way, so hopefully you can see that right away we're having a very large drop in pH. Now remember, when we talked about pH, the pH scale is logarithmic, much like the Richter scale that they use to measure earthquakes. So when it drops by 1 unit, when it drops, say, from 7 to 6, it's not just maybe 1 time more acidic. When it drops from 7 to 6, that's 10 times more acidic. So when it drops from 7 to 6, that's 10 times. When it drops from 6 to 5, that's another 10 times. So if it drops 2 units, say from 7 to 5, that's actually 10 times 10. So that's 100 times more acidic than the original solution. Now we see this seems to have stabilized at about 5.07. So I'm going to stop this. And we can see, if I rescale my graph, that we were at about 7.2, and we dropped down to about 5.0 or 5.05. So that is a tremendous drop just from the carbon dioxide that we were able to add here. Now obviously this is a very accelerated delivery of carbon dioxide. This is not exactly how we're talking about what would happen in the natural systems, but it allows us to very quickly see how carbon dioxide added or dissolving into water can have a huge effect on the chemistry of that water.